YouTube? Woo! Mr. Kane coming at you live in the studio. Here are the questions for the day. Please pause the video now and answer them. Number 3, note, it is a math problem. Hopefully you don't need a calculator for it. Your answer should be between 200 and 90. Your answer, if you got it right, it should be somewhere between 990 and 200. All right, here are the questions from the attendance surveys. Someone asked, should people plant small trees around their yard so it can make oxygen? Yes. In photosynthesis, plants take in CO2 to build themselves, and then they release oxygen. Since trees release oxygen, you'll have high quality air in your home and your backyard if there are more plants. What are the types of energy are renewable? Nuclear fusion, electricity, dams, solar, windmills. That's all stuff that you can use again and again. Pretty much the only non-renewable things that I can think of are coal and gas. When you burn something, it's really hard to get all the energy back. Someone asked, how does a Hoover Dam make more energy? So basically how it works is dams run water over turbines, and then they convert the mechanical energy into electricity. I'll show you. Oh, it's called hydroelectric power. So they'll have this dam run over a turbine that'll spin these coils. So they'll run water over this turbine that'll make the turbine spin, burning the water over it, and then the coils will move. And when the coils move, that'll generate electricity that will go into the power lines. That's how it works. It's pretty cool. Here's some announcements. Our first exam will be tomorrow. It'll be open notes. And today you should be able to calculate how much energy you need to melt gold down into a wedding ring. So the assignment today, go to classwork, go to Wednesday, practice test. Okay, and here we go, number 1. So put your name on it, and then here are all the things you need to do to get an A on the test. Number 1, the practice test works best if you take the test first. So try all 6 questions by yourself. And then after you watch the rest of this video, you can see and learn from your mistakes. That's the way that you learn the best, is if you try yourself and then you learn from your mistakes. Okay, so please pause the video now and take the test yourself. And then I'll go with the answers. Okay, hopefully you took the test. Number 1, below there are 3 different arrangements of molecules determined in the phase of each. So remember, solid is a lot more compact. It's also symmetrical. Whereas liquid is somewhere in between. Well, it's not symmetrical, but it's a lot more compact than a gas, which is very spread out and all over the place. And the gas is more kinetic energy because the gas molecules are moving faster. If you're able to do it, put yes. If you couldn't do it or you need to see the answer first, then put no. If you need extra practice, look at my video and check your States that Matter notes. So remember, it is open notes. So if you don't know what like exothermic means, you can just look it up in your Google Drive and then pull up notes that you took. Here's one of my students that always takes good notes. So like she can easily just look up what endo and exothermic means if she forgot what the words mean. Next one below are 2 diagrams of reactions, one of melting ice and one of a campfire. Explain which one is endothermic and exothermic. Use terms like heat, energy, system, surroundings, endo, and exothermic. Okay. Note when I'm grading, I want you to use this word because. If I tell you you need to explain something, I'm looking for that word because. So when you see the word explain, I want you to think I need to say because. So, for example, ice melting is endothermic. The explanation is endothermic because the ice is the system. So the ice is what we're focusing on, and the system absorbs heat. That's what makes it melt, because it's absorbing heat. Okay, the opposite is fire burning. Fire burning is exothermic because, that part's really important, that's the explanation, because the fire releases heat, and usually try and get all the words in the one I tell you to use words, I want to try and use all of them. So I still need to use surroundings and energy. So how about I just say fire releases heat, energy to the surroundings. Boom. And then I'm going to bold all the words that I used so Mr. Keen has an easy time reading this. Okay, so this was not one of them. But heat was, energy was, exothermic, and surroundings. That's all the words. That would be an A+ response. Were you able to do this? Yes. If I couldn't, I would watch this video. Next one, number 3. There are 100 joules of chemical energy in your firecracker, and after you light the match, 90 joules of kinetic energy launch the firecracker into the air. What happened to the rest of the firecracker's energy, and how much energy is left over? When you read this, I want you to think, law of conservation of energy, energy doesn't get destroyed or created, just changed. So what I was really looking for here is for you not to say, you shouldn't say that the energy disappeared, just tell me where else the energy could be. Okay. The energy went into, you could say went into the air, and hopefully you put in the form of, you can say like light, thermal, or some of it probably stay behind it in chemical energy. Hopefully you didn't just say went into the air. I would like for you to put some form of energy that it went into. We didn't really go over sound energy, but it's true. Some of the energy went into sound. Okay. And then I also asked you how much energy is left over. So if you start out with 100 joules of chemical, 90 of it went into moving the firecracker. So you have 10 joules of energy are left. You're able to do it, but yes. Move on to number 4. Number 4 is a little tricky. If you see a big, intimidating problem like this, here's what I want you to do. Read the problem one time, and then I want you to reread it and underline the important info. So a lot of people say, when you read something, underline the important stuff. You want to read the problem first, so then you figure out what it's asking, and then go back, read the problem, and figure out what is important, and underline it or highlight it. Okay. Kirito just won a golden brick and wants to propose to Asuna soon. Kirito wants to melt the brick down into a ring for his partner. You know that the brick is at room temperature, 20 degrees, but the gold needs to be 1,000 degrees to melt down. How much heat energy will Kirito need to melt this 24-gram Lego brick? So you should notice this is a Q equals MCAT problem. I need to find what I need and what I already know. So I'm going to reread that problem and underline the important stuff. Kirito just won a golden brick and wants to propose to Asuna soon. Don't need to know that. Kirito wants to melt the brick down into a ring for his partner. Don't need to know that either. You know that the brick is at room temperature. That's important. 20 degrees, but the gold needs to be 1,000 degrees. Now I have my delta T, because I just gave you 2 temperatures. So you should remember, if I have 2 temperatures, I need to subtract them to get delta T. How much heat energy? So now I'm asking about how much of the Q, how much heat energy will Kirito need to melt 24 grams of this Lego brick? I also use the specific heat of gold, 0.129. Now I underlined all the important stuff. Now I have everything that I need to solve the equation. So I'm looking for Q. M is 24. C is 0.129. And delta T is 1,000 minus 20. So I'm going to pull up a calculator. Q is equal to MCAT. So Q is equal to 24 times C, which is 0.129, times order operations you need to put in parentheses, 1,000 minus 20. The answer should be 3,034.4 0.8 joules. 0.8 joules. And please put your work. Tell me like what you get for M. M equals 24. C equals 0.129. Okay, cool. If you were able to do that, put yes. If you weren't, you need to review. Last one, reread the problem, and then read it, then reread it, and figure out what's important. Okay? This one is very simple. After you read it, you should just notice you just need to tell me what happened to the water. So I started out with 10 ounces of water. After I boiled it, 7 ounces were left. You should notice the water didn't disappear. The water evaporated and was converted into steam. If you're able to understand that, put yes. Next one, this one's a little bit long. Read the problem, then reread it. The important information is that sodium plus chlorine goes into sodium chloride salt. And then you should note that 25 grams of sodium go in and 50 grams of chlorine also go in. But 6 grams of the sodium did not go through. So this is going to be a law of conservation of energy problem. To figure out how much got made, use 25 grams of sodium plus the 50 grams of chlorine, but 6 grams did not go through. So 25 plus 50 minus 6, 69 grams. Okay. That was the last one. If you got all of those right, you're going to do great. And then take the attendance survey before you go. Thank you so much, everyone, for watching the whole time. Have a great day.